Hi there, this is Chantel, and I am here to finish our lecture on exponential functions, section 4.2. We stopped right when we got to applications, which you should have a notes packet for this lecture, and you should be on section or page 9 of that notes packet. At the top it says applications. A common one is money. So that is what we're going to talk a lot about right now, because these exponential equations are very applicable to money and how it grows and how it depreciates and that kind of thing. So the first thing we're going to talk about is compounded interest. Compounded interest can be savings or it can be a loan. It can be either one. In this example, in this equation that we're going to use, the money is compounded at regular intervals. Okay, so that is something you definitely want to get in your notes. If I'm going too fast, remember that you can pause anytime. Okay, so the first thing you need to do in that great big space there is nice and big, get this compound interest formula into your notes. So this is the formula that's the most applicable to any compound interest problem that you're going to be working on, again, whether it be savings or a loan. So pause and write down this formula. Okay, so hopefully you've got this down and you've left some space around it to fill in each of these blanks. So this first one is the amount. Okay, so amount basically means how much do you end up with? How much do you end up with? Then this next one is the principal. Okay, so that's the principal. The principal is what you start with. So make sure you understand and you have in your notes what you start with. Okay, it's the amount of money you put into your savings at the beginning. It's the loan amount that you took out at the beginning. Okay, so that's the beginning amount that you either loaned or saved. So make sure you have all of that in your notes as well. All right, the next thing is the interest rate. Now this needs to be a decimal. So if the interest rate is 7%, remember that you need to change that to a decimal. So that is 0.07. Okay, 7% is 0.07. Okay, the next thing that you need to know is what n means. N is the number of times the interest is compounded per year. So keep in mind that they're not going to tell you the number of times. They're going to say things like quarterly. So what does quarterly mean? Quarterly means every 3 months. So that means it's going to be 4 times per year. 4 times per year. That's my shorthand for times. Sorry, I wrote that to be brief, but then realized it looks like an X. 4 times per year. They're going to say things like semi-annually, and that means twice a year. Okay, 2 times per year. So just be careful that you understand the words that they're using in these problems. All right, the next one is T, and that is always in years. Always in years. So if they tell you in months, you have to convert it to years. Okay, so make sure you have all of this down before you move on. Okay, the next kind of interest that can grow is continuously compounded interest. So basically this is continuously compounded, which means every single moment interest is being added up. So this can be either a savings or a loan, just like before. This is compounded continuously rather than at intervals. So make sure you have that down. The next thing you want to do in that big blank space is really nice and big. Put A equals PE to the RT. And I'm going to tell you what each one of those means, so leave some space around it so that we can go over each of those. Okay, so one way I remember this is this spells PERT. So if it helps you to remember it. So continuously compounded is A equals PERT. All right, A again is the final amount that you get after it has grown interest or built up interest in a loan. The next one is the P is the same thing. Again, this is the principal. This is the initial amount, what you started with. So make sure you understand what principal means so that you can decipher the problems. The R is the same thing again. It's the interest rate as a decimal, so I'm not going to go over that again. And time is always in years. Okay, so you don't have to know what n is in these. There is no n. There's no compounded quarterly or compounded yearly or whatever because it's compounded continuously. So the n is not present in this equation. So make sure you have all of that down nice and big in your notes. Okay, so we're going to do some problems here because that's the best way to see how these really work. So this first problem, we are looking at investing $2,500 into a savings account. And in A, we're compounding it monthly. And in B, we're compounding it continuously. And everything is the same. So we're going to look and see which one is better. And we're also going to talk about which equations we're going to use. So for A, what I would suggest doing when you start this is to figure out first, what equation are you using? So the first one is compounded monthly, which means we're going to be using A equals P times 1 plus R over N to the power N times T, N times T. So that's what I want you to get in the habit of doing very first thing before you do anything else. And the next thing I want to see you do, and I'm going to ask you to do this on the quiz, is write every single variable down. So, and I'm just kind of going across from left to right looking for every variable, A, P, R, N, and T. And I promise if you do this, you will have a better time with these word problems, with all word problems, if you would just write down the equation and write down all the variables. Okay, so the question is, what is the amount? So after the A, I'm going to put a question mark. And then it says $2,500 is invested. So that is our P, that's our starting amount. So 2,500 goes here. And then the next thing in our list here is the rate. So let's go look for that. The rate is 5.5%, which means 0.055. And then the next thing is N. And N is how often it's compounded per year. How many times? N stands for number of times per year. So if it's monthly, that means it's going to be 12 times per year. And it's 4 years, so the time is 4. Okay, so now all it is plug and chug. You don't even have to rearrange this equation. So we're just going to say A equals 2,500 is P. And this is why we have the equation right here, because then we can use everything as we go and we are less likely to mess up. 1 plus, I'm going to leave the first 0 out, but 0.55 over 12 is N, all to the power of 12 times 4. Okay? So if you put this in your calculator, you don't have to do step by step. You can just put the whole thing in your calculator. If you know how to do your calculator and use parentheses and things like that properly, you should get, and definitely try this right now. So pause the video and see if you get on your calculator 3113.63. And if you don't get that, make note of it and ask me in class. Okay, so that amount that we got was $3,103.63, and now we're going to look at what we get if we do it, if our money is compounded continuously. So which is going to be better, basically. So that equation is A equals PERT, P times E to the RT. Now you don't take P to the RT, just E to the RT. So people ask me in class what E is for. It's for money, basically. We use it a lot for money and other things that grow with this particular function in nature. There's a lot of things in nature. So the first thing I want to see you do again is A equals P equals, we don't have to say E equals because it's just a number that's in your calculator, and R equals and T equals. So in this one, again, we're looking for A. We want to know the amount after 4 years. The principal is the same, 2,500. The rate is the same, 0.055, and the time is the same, 4 years. Okay, so now we're just going to plug everything in. A equals 2,500 times e to the r, which is 0.055 times 4. And I would highly recommend using parentheses. It may not work if you don't use parentheses. So you really need to get those parentheses around the 0.055 times 4, and then it should work out okay. So try that on your calculator real quick. Pause the video, and then come back and see if you get it right. Okay, so you should get 3,115 and 19 cents. So when we're talking about money, you always want to go to the hundredths place because that's pennies. So we don't go past pennies in our money system. So you're going to stop at the hundredths place. So my question is, the difference here is not that great. So here is monthly, and this one over here is continuously. The continuously is a little bit more. But imagine you had $100,000 and you had 20 years to wait. Which one would you choose? Most likely the one that compounds continuously because you will make more money. All right, let's move on. Okay, here's check it out 8 for you to do and put your answer in the Edpuzzle. This problem is exactly the same as what I just did, and you will just repeat it for the 2 different equations and answer it please as A is equal to and B is equal to, and that's all I need to see. I don't need to see your work. Okay, the solution is here, which I'm not going to spend much time going through, but please make note of everything, and if you have any questions at all, bring them to the beginning of class next week. Okay, so this problem that we're going to work together is, the question isn't actually there because it's in the book and the question is elsewhere, but the annual salary of an employee of a certain company starts at $10,000 a year and is increased by 5% at the end of every year. So what we're supposed to find is an expression for the annual salary. So if we just said in 20 years, how much are they going to make? We don't have to work it out year by year. We can just plug it into a formula. So we're finding a formula for, basically this is appreciation. So something appreciating. So we're going to start by putting in our table that you have in your notes, we're going to start with 0. So the very beginning, that's 0 years, we're going to find out an expression and what the salary is. So we know that the salary the first year is $10,000. Okay. And after 1 year, it's going to go up. After 2 years, after 3, and we're going to do 4 of these. Okay, so the expression for the annual salary is basically $10,000. That doesn't tell us much, but there's not much more we can go on when they first start. But after a year, and this is where people have a challenging time with this, so take a moment, pause after I say this, and think about it if it doesn't make sense. So that's the joy of a video. You can stop and think about things. All right, so the expression for the annual salary is going to be, it's going to go up by 10%. So we take 10,000, the amount that they're making when they start, and we're going to multiply it by 1 plus 0.05, 5%. In other words, we multiply it by 10,000 multiplied, that's supposed to be a comma, by 1.05. Okay, so if that doesn't make sense, stop and think about it for just a moment. So when we do that, we're going to get 10,500. So it increased by 5%, 10,500. Okay, so the next year, it goes up from the previous year. So the previous year is 10,000 times 1.05, which is 10,500. And then we multiply that by 1.05. So we basically take the 10,500, which was the original 10,000 times 1.05, and we multiply it by 1.05 again. So do you see what's happening here? Think about that for just a second. We've got 10,000 times 1.05 squared. All right, so then we get 11,000, and I'm less interested in this answer over here than what the expression is, but I just wanted you to see what the annual salary would then be. And as you can imagine, this continues on. So at 3 years, we're going to make what we made the previous year, which is 1.05 squared, the previous year, times another 1.05. So going to go up another 5%. So as you can see, we have exponential growth happening here, 1.05 cubed, and that gives us 11,576. And if you put this in your calculator, you'll see you get some cents, so, and 25 cents. Okay, so the next year, we're going to get the same thing. This is the last one I'm going to do. The expression would be the previous year, 1.05, the salary from that year, which is 11,576 and 25 cents. And then it's going to go up another 5%. Okay, so last one I'm showing you, and that is going to be 10,000 times 1.05 to the fourth. Okay, so that gives us 12,155 and 6 cents. So I would like it right now if you would pause the video and go do those on your calculator and make sure you're getting the same answer. I hate it when people miss problems in math because they just didn't know how to put it in their calculator. So if you have any problems, make sure you check with me at the next class. All right, so now we need to come up with an expression. So if I say in 20 years, how much are we making? So notice that this number is the exponent right there, okay? That number is the exponent. So basically, our expression, and we can just make up variables, so make it so it makes sense. So our salary dependent on time. That's how I'm going to say our function is an S for salary, and T is the independent variable, is going to be 10,000, our base salary when we started, times 1.05 raised to the T. And that's it. So now if I asked you how much money would you make in 15 years, 20 years, 25, you could just plug that year in for T and find out what your salary would be. Okay, this next example is very different, and it may take a moment for you to think it through. So please pause it as we move along, and I'll tell you when is a good time to pause. So this is depreciation instead of appreciation. So you have to think through this a little differently. A Honda Civic depreciates at a rate of 8% per year. This means that each year it will lose 8% of its value it had the previous year. So it's losing value. They tell us how much it was purchased for, and then we're going to make a table for its value over the first 5 years, and we're going to come up with a depreciation formula. So the key point that I want to make sure you get into your notes and into your head, somewhere around this table, you need to write with bright colors and a highlighter, use the retained value. Use the retained value. Retained value means if it loses 8%, we're going to take 100% minus 8%, and we get 92%. In other words, 92% is what it retains. This equation only works with the positive, not the negative. So it works with what it keeps, how much it's worth each year. So it's worth 92% of its original value each year. Okay, so if you don't understand that, stop for just a moment, pause the video, go back, think about that. Okay, so at 0, the expression is 20,000 and the value is 20,000. At 1, we're going to take 20,000 and we're going to multiply it times 0.92. I'm going to leave out that initial 0 just for the sake of space. 0.92. So 0.92. And it's going to be worth $18,400. Okay, so that's how you do a loss. You use the retained value of 92%. All right, so the next year, this is going to work just like before. Everything is the same. The equation is pretty much the same, but we're using retained value to make it work out right. All right, so the next year, it starts out at the beginning of the year worth $18,400, and it's going to depreciate again. So we've got, and I'm just going to work this out the long way so you can see what's happening, 20,000 times 0.92, which is what it was worth at the end of year 1, and we're going to have it times 0.92 again at the end of this year. In other words, we've got 20,000, running out of space, times 0.92 squared. Okay, so put that in your calculator and you should get 16,928. All right, the next one is, as you would imagine, the previous year, 0.92 squared, and then times another 0.92. Okay, so we get 20,000 times 0.92 cubed for a value of, at the end of the third year, it's worth 15,000. And this is actually real information from Kelley Blue Book. The source is right up here. Okay, so I'm not going to do this a long way anymore, but basically we're going to get, and you can fill those in the long way if you would like, but for the sake of time, I'm going to say to the fourth, and you get 14,328 and 20,000 times 0.92 to the fifth year is 13,182. So it's a little shocking. It starts at 20,000. After 5 years, it's only worth 13,000. So depreciation is an important thing you need to consider when you're buying a vehicle. So now we're going to come up with a depreciation formula and talk about what each one of these things is. Okay, so take a moment, pause the video, and write down this depreciation formula. Leave some space around it so we can point at the variables and talk about what each one of them are. Okay, so the V stands for value over time, or value dependent on time. Okay, so value is the function, time is the independent variable. C is the cost, basically. The original, so that's where C comes from, I believe, the cost. The original value. All right, A, this is really important that you understand what this means, but this is the retained value. This is not the number they're going to give you in the problem, most likely. They're usually going to tell you how much it loses per year. You have to subtract that from 100 to get the retained value. So however you want to add that to your notes so it makes sense for you. So in this case, it was 0.92. You take the percentage and you change it to a decimal. All right, and T is going to be years since purchased. So years since purchase. Okay, from the purchase value. Okay, so that's all you need to know. Now we're going to try some problems. Actually, before we try some problems, I wanted to show you this picture of the problem that we just did. So that car depreciates this quickly. So in 30 years, it'll be worth like, I don't know, $1,000. So it'll be way down here. So that's a depreciation graph. And we're going to do that in the next problem, which is a check it out problem. Okay, so the next problem is going to be for you to do. This is check it out 9. It's in your notes on page 12, right at the top. It gives you the data for a Ford Focus, and you need to come up with the equation for this, and then you need to graph it. And I'd also like you to find and put into the Edpuzzle the value of the Ford Focus after 5 years and the value after 10 years, and then graph it, which you will not be able to enter into Edpuzzle, but you need to have it in your notes. So try it on Desmos. All right. Okay, so on this one, the first thing you have to do is figure out what the retained value is. If it loses 10% per year, it's going to retain 90% of its value per year. The original equation is V of t equals CAT. So I'd like to see you lining up all your unknowns here like I did. And then I plugged in V of 5 years, which is what I asked you to do, and got 12,990, and V of the value of 10 years is here. And if you just plug in the equation, which is 22,000.90 to the t, so this this value right here would be t, but in Desmos, you need to use X. So you may have figured that out, but put that in. So you're just going to put 22,000 times 0.90 to the X, and then you'll get it. If you put in T, it does some other things often. So this is what your graph should look like as well. So it depreciates pretty quickly. Okay, this is the last problem, and again, one for you to try. It's not a check it out, but it's just one I wanted you to do and give me your answer in Edpuzzle. So according to Kelley Blue Book, the depreciation rate of a Mercury Sable is given, the Toyota Camry is given, and then you need to create a function for each scenario and graph them on the same set of axes. I won't see that, but you'll have it in your notes. What is the value of each car after 5 years and 10 years? And then I want you to tell me which one is a better deal. Okay, so, and why? So this one is going to be more of a written answer instead of a number. So which is a better deal is what I will be asking you on Edpuzzle. So you might want to pause it here so that you can work this problem, and then in a moment it will move forward to the Edpuzzle question of which is a better deal and why is it a better deal. Okay? So first work it out, find the equations, figure out the 5 and 10-year values, graph it, and then tell me which one is a better deal and why. All right, good luck. And that is the end. After the question, that is the end of this. So bring all your questions to class. I wanted to make sure you had the answer to this one. So make sure you have these equations correct in your notes. If you have them incorrect, fix them. The Sable is 18,000 times 0.70t because the retained value is 70%. And the Camry is 25,000 times 0.92, because 92% is the retained value, raised to the power of t. So if you put in 5 and 10 for each of those, these are the numbers you get down below. And if you graph them on Desmos on the same set of axes, you get these two equations that are quite different. All right, we'll see you in class.